Good morning. So this is going over Unit 1, Day 2 notes. Okay. I want you, as a warm-up, to just go over the first page, fill in everything that you can. This should just be a review of quadratics. Go ahead and flip your paper over, so you can pause the video if you would like. And when you're done, go ahead and flip your paper over. We're going to go over these example problems. It says to factor and rewrite the quadratic equation in x-intercept form, but for part A, what's nice is it's already factored for us, right? So I'm going to show you again how to find the x-intercepts, the y-intercepts, and the vertex. This should just be a review for you. The x-intercepts is when we set our y equal to 0. So when we set this equal to 0, we're just solving for x, and we get x equals positive 4 and x equals negative 2. And we're going to write that as an ordered pair. So that would be 4, 0, and negative 2, 0. So we're going to do the opposite when we're trying to find the y-intercepts. We're going to plug in 0, substitute 0 in for the x's. So 0 minus 4 is negative 4 times, so f at 0 is negative, and then negative 4 times 2. Negative times a negative is a positive. 4 times 2 is 8. We're going to write this as an ordered pair. We're going to have 0, 8. And now our vertex. What's really nice is we have a formula for this, at least for my x value of my vertex. X equals negative b over 2a. But in order to do that, I'm going to have to FOIL this. So what I'm going to do is FOIL it, distribute it. X times x is x squared, and then minus 4x plus 2x is minus 2x, minus 8. Distribute this negative. I have x squared plus 2x plus 8.
Nicholas Volpe, please report to the main office.
Sorry, guys. Alrighty. Now I know what my b is. That's the term in front of the x. And I know my a, which is the term in front of the x squared, which is negative. I didn't write it down. Alright, so this is going to be negative 2 over 2 times my a is negative 1. And that is negative 2 over negative 2, which is 1. And now I'm going to plug that into my original equation to get the y value of my vertex. It doesn't matter which one you plug it into. You can plug it into this one or to this one. It's up to you. I'm going to substitute it into this. So we have y equals negative 1 squared plus 2 plus 8, which is 9. And I'm going to write it as an ordered pair, 1, 9. And I'm just going to plot these things on the coordinate grid. Make sure you're labeling your axes every single time. 1, 9 is my vertex. 0, 8 is my y-intercept. And these are my x-intercepts at 4, 1, 2, 3, 4, 0. And then negative 2, 0. And then try to just sketch a graph. Kind of. So this is my parabola. So that's part A. For part B, you're going to do the exact same thing. I want you guys to try it out. I'm going to help you with the first part, since I didn't factor in this one. I'm just going to pull out the common term, which I can see I can pull out a 2 out of every term. So we have 2, and then we have x squared plus 2x minus 3, and then that's easier for me to factor this trinomial. So 2, and then I have my 2 sets of parentheses. I know that x times x gives me x squared, and my factors of 3 are literally 1 and 3. There's no other factors of 3 that I can think of. So I know that when I multiply, I need it to be a negative. So one's negative, one's positive. And then when I add them, I need it to give us a positive 2x. So my bigger number is positive. And I want you guys to try to find the x and y intercepts. Give me the vertex and then graph it. This is a historical note. I need you guys to pause the video and actually read this paragraph, this top paragraph. Pause it now, read it. So this is his question. What must be the square which when increased by 10 of its own roots amounts to 39? Amounts means equal to 39. So this is the equation that he is referring to. There are many approaches to solving this equation, but he chose to add, so we're going to solve for x, right? He chose to add 10 over 2 squared to both sides. Where did he get 10 over 2 squared? Well, I see a 10, and then I don't know where he got 2 from, or if it's 2 every time, and then he squared it. So it says the result equation is, since he added them to both sides, we have something like this, okay? And then he said, which allows us the left-hand side of the equation to become a perfect square. Now that's really what we wanted. So he's making the left-hand side a perfect square. Okay, finish the problem. Let's look at this. I'm just going to rewrite it. X squared plus 10x plus 25 equals 39 plus 25. So since we have a right-hand side of the equation, it's not set equal to 0 or anything like that. What we're going to do is factor it. Well, that's pretty cool, actually. So when I factor this, I get x plus 5 squared. Okay. And on the right-hand side, 39 plus 25 is 64. Okay. Well, that's nice. I can actually solve this now pretty easily. What I'm going to do is take the square root of both sides, okay? So we have x plus 5 equals 8 times 8 is 64, plus or minus 8. And now I'm going to minus or subtract the 5 to move it to the right-hand side. So x equals negative 5 plus or minus 8, okay? So I'm going to just rewrite it. X equals negative 5 minus 8 is negative 13. And then negative 5 plus 8 is 3. Okay, that's pretty awesome. What did we just do? What did he figure out? What is this method called? We learned this in Algebra 2, maybe even before. What do we call this? So we're making a perfect square on both sides, and it's called completing the square. I hope you guys got that. Good. Very nice. Completing the square. Now there's two ways you can do this. These are just example problems. Let's go over the vertex form first. To find the vertex of a quadratic, given the general form, then one approach is to convert it to the vertex form. In order to do this, we're going to have to complete the square. Then the vertex will be at, remember we changed the sign of the one inside the parentheses with the x. We almost do this for anything. So this is going to be positive h, right, because it says minus 8, so my vertex is at positive h, and then k. So just remember, when we take the vertex, when we pull those numbers out, we're going to change the sign of the x value. All right, so now it's up to you. You can move this 3 over to the other side. I'm going to show you how to do it without that, okay? What we're going to do is exactly like the man in the back figured out. We're going to take the middle term, or the b term, negative 2. We're going to divide it by 2, right? And that's going to give us negative 1. And then we're going to square it. We're going to complete the square, so we're going to square it. So I have x squared minus 2x. I'm not changing this. What I'm going to do is negative 1 squared is 1. I'm actually adding 1 to this equation. You can't just add a random 1 to this equation. So over here I have 3, I have a positive 3. And instead of adding 1, I'm going to subtract 1. Since I added 1 here, I'm going to subtract it here. Okay? So this, I can complete the square. I can factor this very, very easily. It's always going to be x, right? And then plus or minus the number in here. So x minus 1 squared. And then this is positive 3 minus 1, which is positive 2, plus 2. Okay? So I just combine these terms right here to get positive 2. And still my function y equals. And this is my vertex form. It's pretty nice. So what I need is the vertex to graph it. My vertex, remember we always change this sign. So instead of -1, it's at 1. And then we are going to keep this sign, so +2. So 1, 2 is going to be my vertex. Oops, okay. And it looks like, it's just positive. I don't know. You guys can figure out some more numbers if you would like, but I'm just going to go up. Ta-da. Something like that. Alrighty. I am going to do one more with you because this one looks hard. So, what we need to remember is we have to factor out anything in front of that x squared. This is a -1 in front of the x squared. We have to factor that out. So I have negative parentheses, and then we have x squared plus 4. And I'm not changing. I'm not going to factor out the 2. So I'm going to put it on the outside of the parentheses, and then the 2. Sorry, 4x, sorry. Okay, so remember, we're just taking this middle term right here, I guess +4 now, and we are going to divide it by 2 equals 2, and then we're going to square it. So 2 squared is 4. But we're not really adding 4 to this equation, right? We're not really adding it because there's a negative out here. So if I distributed that negative, this would actually be -4. So what we're going to have to do, since we are actually adding -4, we're going to have to add a +4. This is actually a -4 if I had distributed this, a -4. So I'll have to put +4. So this kind of gets a little tricky sometimes. You could just remember to multiply it by whatever you pull out, or you factor out. You can multiply that. So this is still a negative, parentheses. You're still going to have to factor this, which is going to be x plus 2, right, squared. And then you're just going to combine these. 2 plus 4 is 6. Y equals, sorry. Alrighty. I want you guys to try C. I'm just going to finish B for you, but I want you guys to try C. Factor out a 2. All right, so my vertex, remember we are changing the sign. So this is actually at -2 and then keeping the sign, 6. And this little negative on the outside means that my parabola is facing downward. So -2, 6 is my 1, 2, 3, 4, 5, 6. That's my vertex. And then this negative out in front means that it's going down. You can find the x-intercepts if you would like. It doesn't ask us to. I want you guys to try C. Using the discriminant, okay? It says x-intercepts or solutions of a quadratic equation are given by the quadratic formula. If all else fails, use the quadratic formula, okay? We can use the discriminant part of the quadratic formula, which is just the inside of the square root b squared minus 4ac, to find out how many solutions there are, if any, okay? If our discriminant, I think this is, the discriminant can be used to determine if the graph, does not cut the x-axis. If it doesn't ever touch the x-axis, then our discriminant, this is my symbol for discriminant, is less than 0. Because that means that it's going to be imaginary, right? We can't have a square root that is negative. That means it's going to be imaginary. If my discriminant touches the x-axis, then my discriminant is going to equal 0. Give me a second. If my discriminant equals 0, then we're going to have one real solution, but it's going to be repeated, okay? So, and then if our discriminant is greater than 0, then we're going to have two unique real roots. So that means no real solutions. Or no real roots. And then one repeated root. Alrighty. Use the discriminant to determine the relationship between the graph and the x-axis for these. Let's try this one because it looks harder. It looks more difficult. Alrighty. So I'm just going to look at the b is 4 square root of 2. And then I need a and c. So a, so this is b. A is 1. And c is 8. So I'm going to say, well, what is 4 squared root of 2? B squared minus 4, right? 4. A is 1, and C is 8. 4 squared root of 2 squared, we do have to distribute the squared, which is 4 squared, which is 16. And then anytime we have the square root of something squared, it's just going to be the number inside the square root. The square root and the squared cancel each other out. So we have 16 times 2, and then minus 4 times 8, which I believe is 32. Okay. 16 times 2 is 32, minus 32, this equals 0. So we're going to have one real solution. Okay, it's going to touch the x-axis. Actually, our vertex is going to be on the x-axis, right? So you can say one real solution, one repeated root, whatever you want. Go ahead and, so I want you guys to try A. Go ahead and flip your paper over. So let's try number 4. It says find the values of m for which the equation has a repeated root. 2 distinct roots, and then, okay, so no real roots. So A, I know that it has a repeated root when my discriminant equals 0. So that's exactly what I'm going to do. So when it does, the discriminant equals 0, my discriminant is negative b, sorry, b squared minus 4ac. I always have to do it in order. I have to say the whole thing. B squared minus 4ac. So negative 5 squared minus 4, a is 1, c is m. Has to equal 0. When that equals 0, we'll have one, let me just keep it in green, one repeated root. All right, 5 squared, negative 5 squared is 25 minus 4m. Subtract the 25 to move it to the other side. Negative 4m equals negative 25. And then you're just going to have to divide by negative 4 and get when m is equal to just 25 over 4. Just leave it like that. Leave it as a fraction. Simplify it if you can. You can't simplify this one. Okay, this is if we wanted a repeated root. Let's try b. b is when we want 2 distinct roots. So that's when our discriminant is greater than 0. Okay, so whenever my discriminant is greater than 0, well, let's figure that out, but this should be pretty easy. That's when negative 5 minus 4ac, right? So 25 minus 4m is greater than 0. So I'm still going to subtract the 25, divide by 4, but specifically, well, let me actually show you this. So subtract the 25, negative 4m is greater than negative 25, and then divide by negative 4. But remember, when we divide by a negative number, we're actually going to flip our sign, right? So we have m, whenever m is less than the 25 over 4. So that's why I wanted to show you this. Okay. Less than 25 over 4, that's okay. So we know the opposite will be when there's no solutions, no real roots. So let me do C. When my discriminant is less than 0, there's not going to be any real roots. And it's going to be the same thing. We're just going to make this less than. When I divide by -4, it's going to flip. Whenever my m is greater than 25 over 4. You can work it out if you would like to. Promise. All right, example 5. It says, when are these two functions tangent? Tangent means that they're going to intersect one time. Okay? They're going to touch at one place. So that means that they're going to be tangent when the 2x minus k plus k equals 2x squared minus 3x plus 4. So when are these two tangent? Well, we know that's going to be, they only intersect once. When my discriminant is equal to 0, they're only going to intersect once. So let me just make this equation. I'm going to move everything to the right-hand side since my 2x will be positive. So I'm going to subtract, sorry, the x squared will be positive. So I'm going to subtract the 2x and actually subtract k. So I'm going to be left with 2x squared minus 5x plus 4 minus k whenever this is equal to 0. And this is actually going to be my C term. Okay, this right here is going to be C. So I'm going to plug it into the discriminant because we know when our discriminant is equal to 0, then this is when we're going to have one solution repeated. So this is the only time we have one solution. So I'm going to just substitute this in. Remember, it's b squared, which is -5 squared, minus 4a, which is 2, and then c, which is 4 minus k. This is a really good IB question, actually. -5 squared is 25. And then I have -4 times 2, which is -8 times 4 minus k. Equals 0. Give me 1 second. Okay, let's finish this. Let's just simplify it. So we have 25. I'm just going to have to distribute this. So 8 times 4 is 32. And then we have plus 8k whenever this equals 0. Combine like terms, 25 minus 32, and then you're going to divide by 8. We're going to get k equals 7 over 8. 32. Perfect. Alrighty. So that's k. I want you guys to try number 6. And then I want you to work on number 7 and number 8, okay? Have a wonderful day, and I will see you in class.